Hello dear students. So in this video we solve this example regarding the eigenvalues and eigenvectors using Jacobi methods. This question is asked in VTU 2026 examination for AI and CS branch. So let's see the solution. Solution. So here we are given a 2 cross 2 matrix here, that is a symmetric matrix. So the Jacobi method is applicable only for symmetric matrix. So this matrix we have to find eigenvalues and eigenvectors using Jacobi method. So let us write the matrix first. What is the matrix given here? 4 1 1 4. Is it clear, student? Now let us consider the largest. So largest off diagonal element. Off diagonal means the non-diagonal element. What is the diagonal of this matrix? This is the diagonal. This is the diagonal. The diagonal elements are 4 and 4. So let us consider the largest off diagonal. Off diagonal means non-diagonal element. Which are the non-diagonal elements here? 1 and 1. So the largest off diagonal element is, so that is 1. So that 1 is situated at which position? That is first row, second column. That is, if you consider this one as A11, A12, A21, A22. So the largest off diagonal element is A12, that is equals to A21. Because since it is a symmetric matrix, these two elements must be same. So therefore A12 is equals to A21. So the value of this largest off diagonal element is 1 only. Is it clear, students? Now let us find the rotational angle. So rotational angle, the formula for rotational angle is given by theta is equals to 1 by 2 tan inverse 2 times of Aij divided by Aii minus Ajj. Is it clear, student? This is what the formula for to find the rotational angle. So theta is equals to 1 by 2 tan inverse 2 times. So here Aij means the largest off diagonal itself only. What is the largest off diagonal element here? A12 divided by what is I value? 1. So therefore A11 minus J value is 2, A22. Is it clear, student? Now substitute the values. So 1 by 2 tan inverse 2. What is A12 value is 1. Is it clear, student? So A12 value is 1. So 2 times of 1 divided by what is A11 is 4. 4 minus A22 is 4 again. So here we got that 1 divided by 2 tan inverse 2 by 0. What is 2 by 0 is? So obviously that is infinite. So 1 by 2 tan inverse infinity. So what is tan inverse infinity is? What is tan inverse infinity? When tan is infinity, so that is at pi by 2. That is at 90 degree angle. So the rotational angle is pi by 4 only. 1 by 2 into pi by 2 is pi by 4. So the theta value is pi by 4. Is it clear, students? Now let us consider the rotational matrix or the orthogonal matrix. So consider the rotational matrix. So what is the rotational matrix here? So S1 is equal to, since it is a 2 cross 2 matrix, so we have to consider this one as the rotational matrix. So that is cos theta minus sin theta and cos theta. This is what the rotational matrix we have to consider. Now substitute the value of theta into this matrix. So that is substitute the theta value. So at theta is equal to, what is the value of theta here? We got pi by 4. So that S1 becomes, so S1 becomes, so this is cos theta. So cos pi by 4 is 1 by root 2. So this one is minus sin theta. So sin pi by 4 is again 1 by root 2. So since we have minus, so therefore minus 1 by 2. This one is sin theta. Sin pi by 4 is again 1 by root 2. And this is cos theta. Cos pi by 4 is 1 by root 2. Is it clear, student? So to apply the Jacobi method, so we have to find the inverse of this rotational matrix. So the inverse of this rotational matrix is given by, so since it is an orthogonal matrix, so the inverse of this matrix is its transpose only. So that is S1 inverse is equals to S1. So simply just we have to take the transpose of this matrix so that we will get the inverse. So that is, what is transpose means? Interchange the rows and column. Means first row becomes first column 1 by root 2. This element becomes here minus 1 by root 2. Second row becomes second column. So 1 by root 2, 1 by root 2. Is it clear, students? Now we got the S1 inverse. Now consider So consider what we have to consider here. So we have to consider the matrix multiplication S1 inverse A S1. So this one we have to consider now. So what is this means? S1 inverse A S1. So you should not consider S1 A S1 inverse. S1 inverse. So first comes the S1 inverse followed by A, lastly followed by S1. So substitute the values. What is S1 inverse is this matrix. 1 by root 2, 1 by root 2, minus 1 by root 2, 1 by root 2. So this is what the S1 inverse is. What is A given? A is the given matrix. So that is 4, 1, 1, 4. This is what the given matrix. So lastly S1. What is S1 value? This is 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. So this is what the S1 is. So to make the calculation simpler, take 1 by root 2 common from the first and third matrices. So take 1 by root 2 common from first matrix and also from third matrix. So 1 by root 2, 1 by root 2. So if you take 1 by root 2 common from the first matrix, you are left with 1, 1, minus 1, 1. So this one is as it is 4, 1, 1, 4. So this one, if you take 1 by root 2 again common, so you are left with 1, minus 1, 1, 1. Is it clear, student? Now we have to multiply these three matrices. So 1 by root 2 into 1 by root 2 is 1 by 2 only. You can either multiply these two matrices first, these two matrices first. Is it clear? That's your choice. So here I will multiply these two matrices first. How to multiply two matrices? Row by column. First row by first column. So 1 into 4, 4 plus 1 into 1, 1. That is 5. So now first row, second column. 1 into 1, 1 plus 1 into 4, 4. That is 1 plus 4 is again 5. So here second row, first column. That is minus 1 into 4 is minus 4 plus 1. That is minus 3. This one is second row, second column. Minus 1 into 1, minus 1 plus 4 into 1, 4. So that is minus 1 plus 4 is 3 only. So keep this last matrix as it is. 1 minus 1, 1, 1. This matrix as it is. Now keep the 1 by 2 as it is. Now multiply these two matrices again by row by column. So how to multiply by row by column? First row, first column. 5 plus 5, that is 10. So first row, second column. Minus 5 plus 5, 0. Second row, first column. Minus 3 plus 3, 0 again. And second row, second column. Minus 3 into minus 1 is plus 3. And 3, that is plus 3 plus 3, that is 6. Take 1 by 2 to inside. So that is 10 divided by 2 is 5, 0, 0. 6 divided by 2 is 3. So now we got S1 inverse A S1, that is equals to D. So D is a diagonal. D means diagonal matrix. Means we converted this matrix into a diagonal form. So what is diagonal matrix means? So non-diagonal elements are 0 here. Both the non-diagonal elements are 0. So only diagonal elements are non-zero here. So therefore it is a diagonal matrix. So say or let means I am letting that as D. So therefore the required eigen values are, so what are the eigen values here? The diagonal elements are the eigen values itself. So our eigen values are lambda 1 is equals to, what are the diagonal elements here? 5 and 3 are the diagonal elements. So they are the eigen values. So lambda 1 is equals to 5 and lambda 2 is equals to 3. So these are what the eigen values. Now to find the eigen vectors, now the eigen vectors are so what are the eigen vectors here? So this 5 is situated in the first row, first column. So we have to consider the first column of S1 matrix. First column of S1 matrix as a first eigenvector. So for lambda 1 is equals to 5, what is the eigenvector? The eigenvectors are usually denoted by X, that is capital X. So x1, first eigenvector is, so this 5 is situated in first row, first column. So the first column in S1 matrix is 1 by root 2, 1 by root 2. So that is what the first eigenvector. And for second, what is the second eigenvalue? 3. That is situated in the second row, second column. So we have to consider the, for lambda 2 is equals to 3. What is the second eigenvector? x2 is equals to the second column in the S1 vector matrix. So what is the second column? Minus 1 by root 2, 1 by root 2. So x1 and x2. These two are the eigenvectors, and lambda 1 is equals to 5 and lambda 2 is equals to 3. These two are the eigenvalues of given matrix A is equals to 4 1 1 4. Is it clear, students? Thank you.